Hello class, this is Dr. Fenton. I thought I'd create a quick video here to show you how to compute direct materials and direct labor variances. I'm going to use as an example exercise 10-6 in the back of chapter 10 in your textbook. This is just like question 8 in your module 5 homework. So let's cover this, and it should help you with those several questions in your homework that deal with materials and direct labor variances, and probably will help you with the overhead variances. So let's get started. In exercise 10, we're going to see that we have direct materials. This is the standard. The standard calls for 4.6 pounds of direct materials for each unit produced. The standard calls for us paying $2.50 per pound. Direct labor, we should use 0.2 hours for each unit produced, and then that should cost us $18 an hour. So let's compute the materials price variance and the quantity variance. Now for the price variance, we have to look at the number of pounds of material purchased. Whatever the units are of the materials, it could be pounds, ounces, square feet or whatever. Here we have pounds. So we purchased 20,000 pounds of material, and it cost $2.35 per pound. Now this is the actual cost. The standard calls for us to pay $2.50. So you can see we are 15 cents a pound lower in our actual payment than what the standard called for. So you'll know that when you finally get the answer for the materials price variance, it's going to be favorable because we paid less actually than the standard called for. What we'll do is just take that difference, that 15 cents times 20,000 pounds, and that's going to be the answer. So let's look at this. So you can see in this chart format that I like, I think it's an easy way to compute the variances. And the first one is the materials price variance. Here's the 20,000 pounds we purchased. Here's the 20,000 pounds we used. Oh, excuse me. Yeah, we used this and purchased this 20,000 pounds. And we paid $2.35 per pound. The standard called for $2.50. Multiply these out, 47. This is 50,000. So $3,000 is the materials price variance. As I explained earlier, another quick way to do this is to find the difference between your price paid, $2.35, and your per pound amount that the standard calls for, $2.50. That's 15 cents a pound times 20,000 pounds. You get the same number. And again, it's favorable here because you actually paid less per pound than the standard called for. Let's go back to the question for the quantity variance, and here you're going to compare the quantity used, the quantity of materials used, with what should have been used based on actual output. So in this problem, all the material that was purchased was also used. So we did use 20,000 pounds, and then we produced 4,000 units. Now how many pounds should we have used based on the standards to produce 4,000 units? The standard calls for 4.6 pounds per unit. So we should take 4.6 pounds times 4,000 units to get the quantity we should have used. So let's look at the solution. And here they have it down here. 4,000 units times 4.6 pounds that the standard calls for. We should have used, based on the standards, we should have used 18,400 pounds. Drop that number in here. We actually used 20,000 pounds. So again, in this problem, we purchased and used 20,000 pounds. So we use the standard price in each of these columns. So the difference here is not the price, but the quantity. Quantity used compared to quantity we should have used based on actual production. So you can see the answer is $4,000, unfavorable. Why is it unfavorable? Because we used 20,000 pounds, which is more than we should have used, only 18,400 pounds. Another quick way to compute this variance is to take the difference between these amounts. 20,000 minus 18,400 is 1,600 pounds. Take that times 250, you'll get the same answer, 4,000, unfavorable. So that's the quantity variance. Now net these two together. You net the two together because one's favorable, the other one's unfavorable. So subtract and find the difference, $1,000 of course. And since the materials quantity variance is larger than the price variance, we stick with the unfavorable amount here. So the entire spending variance is 1,000 unfavorable, broken down between the price variance, 3,000 favorable, and the materials quantity variance, 4,000 unfavorable. Now let's compute the labor rate and efficiency variances for the month. Now the rate variance will be the difference in what you paid per hour compared to what the standard called for. And we can see here that we used 750 hours of direct labor time. That cost us a total of $14,925. Now if you get your calculator, and I'll do it right quick to the side, you cannot see this, but if you take $14,925 total labor cost and divide by 750 hours, you will get $19.90 per hour. So that's the actual direct labor cost, $19.19. The standard said we should have paid $18 per hour. So we paid more than the standard, so we're going to have an unfavorable labor rate variance. So let's look at the chart. And here's what I did a minute ago. I took $14,925 divided by 750 hours to get the $19.90 per hour. Now you didn't have to do this. You can just leave the $14,925 here if you want to and compare it to the number you get over here. But I wanted to show you the breakdown and actually show you the amount per hour you actually paid. Over here, at 750 hours that we used, we should have paid $18 per hour according to the standard. So it should have cost us only $13,500 in labor cost. It cost us $14,925, which is higher. Therefore, the labor rate variance is unfavorable. We paid more than we should have per hour. So the labor rate variance is unfavorable. Let's look at the information for the efficiency variance. Here we need to find how many hours should we have used based on our actual production. The standard calls for 0.2 hours per unit. We produced 4,000 units. So you take 0.2 hours per unit times 4,000 units, and you'll see that that is 800 hours. So we produced actually 4,000 units times the standard per unit, 0.2 hours. So we should have used 800 hours, drop it in here. We actually used 750. So we used less, fewer hours than we were required to according to the standard. So the labor efficiency variance is favorable. So we take this total, 750 times 18, 13,500 again. Subtract it from this amount. The standard hours we should have used based on our actual output, 800, times 18 per hour. We use the standard hourly rate in each of these columns here. So the amount here is higher. It's favorable. Again, favorable because we used fewer hours than we were required to according to the standard. So it's favorable. Again, one is unfavorable, the rate variance, other one favorable, efficiency variance. Subtract and find the difference. And since the labor rate variance unfavorable is larger than the efficiency variance, which is favorable, we have a spending variance overall of 525 unfavorable. So the main thing on the efficiency variance as well as the quantity variance for materials is you need to find, for materials, the amount you were supposed to have used based on your actual output. We produced 4,000. The standard called for 4.6 pounds. Multiply, we should have used 18,400 pounds. For the labor, we actually again produced the 4,000 units. The standard called for 0.2 hours, just a portion of an hour for each unit. That means we should have used 800 hours to produce those 4,000 units. Drops in here. So again, you need to find the amount of units we should have used based on our actual production. So that's a quick overview of those two standards, those variances. So again, go back into your chapter, review the examples, and good luck with your studies.